Okay. Uh, Hello, greetings, everyone, and welcome in to my channel. I am Professor L, and I am doing this live stream for Math Help. So, um, my end goal is to get really good at presenting math for camera and maybe possibly helping some students along the way. I don't think anyone in um, the world should be bad at math or at least not aware of math and knowing how to do it. All right, so we are going to continue discussion on rational functions today. A reminder, if you do need help with your math and you have a math problem that you would like to post in the chat, you're welcome to do that. And I'll take a look at it and see if I can help. What I've decided to do today is continue the rational, graphing rational functions. And so I'm going to try to get right into it because what I decided to do is pick a brand new function and evaluate it and graph it all so you can see the full process. And we'll just see how it goes. All right. So we're going to keep in mind these critical values, but we're also going to be finding the x and y intercepts and also looking at some other key critical values. So we're not going to be doing the transformations, but we're still going to find all the values that we need and make a list. So evaluating the function is a slightly different method, but it's more straightforward. What you're doing is you're just taking the function and plugging in values that you pick from your domain and evaluating it and finding values in your range, essentially. So I'm trying to not think too much about it because I would rather this just be natural as possible for me, and I'm hoping that I'll be as relaxed as possible up here so that I can use my full brain. Okay, that's good enough. Okay. And hopefully I pick a good marker. All right, so what I decided to do is to pick a brand new function entirely, and I picked it out of the textbook that I have. I have an old algebra textbook, and so I'm going to go ahead and put it up here. So we're looking at the function f of x. I tried to pick one with an oblique asymptote, that funny slanted asymptote, and also one that's kind of bending interesting. I wanted to find a little bit better one because this one actually has a pretty, I already looked at it. I was trying to practice so that it wouldn't take me so long. And this one does have an oblique asymptote. However, for that oblique asymptote is cutting the y-axis is causing me to have to change the scale of my drawing. So we'll just see how it goes. Let's get our Cartesian coordinate system out so that when I'm evaluating this function, I want to go ahead and get my graph in here good. Nice big graph. And we'll do the table over here on this side. So we need a table. And remember, any graph, any function that you want to graph, whether it be rational functions, trigonomeric, any kind of functions that you want to graph that you can think of. The process is always the same. Okay, you have a function and you have values in your domain that you want to evaluate. So you select your values of the independent variable. That's why the x-axis is independent. It's because it doesn't, the function depends on what values you pick for the domain. So you select your inputs, you put them in the function, do some algebra, and then you have your outputs over here. So this is input, and this is output, essentially. So we'll just pick values 1, 2, 3, 4, 5, 6, 7, and 8. And honestly, I'm not going to go out further than 5 on this one. So let's go ahead and change these. Let's change the scale just a little bit. Now, of course, I gotta get my eraser out. So we'll go 1, 2, 3, 4, 5. I think that's better. It's more clear. Okay, so I'll erase this one, of course. But again, this is just me practicing, and it's been a while. Whenever you're good at something, you stop doing it. You kind of take for granted the things that you were in practice. Some of the automatic behaviors you develop when you develop a skill. But makes it a little scary, but it's doable. When you learn something once, you can learn it again. Let's see how that scale looks. And I've got a monitor right here where I can kind of see it on camera and see how it looks. It's a bit better. Okay. All right, so we've got our Cartesian coordinate system here. And let's go ahead and very first thing that you want to do is you want to locate your asymptotes. So we'll say step 1, find asymptotes. And looking at this function, you have a general rule. So you have case 1 if, and you're looking at the leading exponent. So the leading exponent is the highest degree exponent in your equation. It should be in descending order. That's considered standard form. But if it's not, you're just looking at the largest one. So here in the numerator, my largest one is 2, because there's a 1 there, it's hidden. And then that's actually 4x to the 0 power. So they all have exponents, whether it's openly stated or not. But this one's a second degree. And then you're looking at the exponent in the denominator as well. And if the numerator is less than the denominator by 1 degree, you have an asymptote at the origin, y equals 0. But if they're the same degree, then you look at the leading coefficients of your variable. And then if the denominator is 1 degree less than the numerator, you have an oblique asymptote. And that's the case here where we have an oblique asymptote. And you use synthetic division or long division to find it. So that's what we're going to do. We're going to go ahead and use long division to find this asymptote. And we're going to divide x minus 3 by x squared. We're going to divide x squared plus 5x plus 4 by x minus 3. And these videos are really holding me accountable, and I have to be very careful about what I say because I've gotten lazy and I don't want to say things backwards and say things wrong. So the method of division is I'm going to take my variable and divide it by this first term. So I have x squared divided by x, and so that's going to give me x. So I'm going to find my x, my linear term, I'm going to put x there. And then I'm going to take that x and I'm going to multiply it by x minus 3. And so that distributive property there, you got x squared minus 3x. And so I'm going to put that here, x squared minus 3x. And I'm going to put parentheses because what I'm doing in the division algorithm is I'm subtracting that when I divided. So when I subtract, I have to make sure that I carry that negative over twice. So while this one becomes a negative, this one actually becomes positive when I do hopefully that makes sense. And I can explain that once. That way, if I have to do it again, you'll understand why I'm changing the signs. It's because you subtract, there's two terms, and you have to carry that subtraction to both terms. So x squared minus x is 0, and 5 plus 3 is 8. So you have 8x, and then you bring that 4 down, and you have 8x plus 4. And then you repeat the process. You're going to take 8x and divide it by x. So you'll have 8x divided by x. And so that just equals 8. And then I'm going to take 8 and I'm going to multiply it by x minus 3 for the algorithm. And we have 8 times x is 8x. And then 8 times 3, well, that's negative 24. Let's see, 16, yeah, 8 times 3 is 24. So we're going to put that here, 8x minus 24. And remember, we have to change the sign. So we're going to subtract there and add there. And we're doing that because we have to subtract that step earlier I showed you. So I need to go ahead, I think I can fit it in here. So let me scoot this one down just a little bit. 8x divided by x is 8. So 8 minus 8 is 0. And 24 plus 4 is 28. I forgot to carry the 8 up here. So this is an 8. So we'll have a plus there, plus 8. Okay, and so this is our remainder. We're finished with our algorithm. So if you're having to do this and turn it into a problem, you would just say 28 and you put it over whatever was in your dividend. So that would be x minus 3, or I guess that would be the divisor. It confuses me because it's been a long time since I thought about the definition of division, but 28 divided by x minus 3. And only thing that we need in this case is this x plus 8 part. This right here. We don't care about the remainder. The remainder doesn't matter. What this is telling me is this is my oblique asymptote x plus 8. So I'm going to go ahead and list this on my key values over here. My oblique asymptote. You can tell how I'm doing in the day when I see if I'm spelling things correctly and how easy it is. All right, so we have y equals x plus 8. Okay, So we have an asymptote there. And I am going to go ahead and erase all of this. Okay. It's the beauty of having it recorded. You can go back and watch it if you need to. There's probably better examples online. These short videos and these clips. Again, that's not the intention behind the design and the setup of this particular live stream. I was hoping that I would get students that wanted to get math help. And, you know, part of that is my fault. I have not been advertising or doing any kind of marketing or doing anything to try and encourage. I feel like maybe later on, after I'm more comfortable and I feel somewhat successful at this, I might be trying to go get an audience. But for now, I'm fine with just having low profile. Especially, it's so new. I'm rewatching all of my live streams to get hopefully good at it and realizing that I, just like I'm doing now, rambling on about stuff that doesn't matter. All right, so I'm just going off on a little tangent there. All right, back to the function. So we also have a value in the denominator that is going to go to 0. So if you've been listening to my lectures the last couple of days about rational functions, we also have a vertical asymptote in the denominator, or when that denominator is going to 0. So you solve so for vertical asymptotes, you solve x minus 3 equals 0. And that's going to tell you what values you're going to make your denominator 0. And you solve this one-step equation by adding 3 to both sides, and you get x equals 3. So this is your vertical asymptote right here. I'll erase it in just a minute. So we're making a list. Of all key values that we're going to use to sketch this graph clean. And this is an equation of a line. It's a vertical line. That's why it's in the form of x equals. Realize my hair's in the way. So it's vertical asymptote, x equals 3. Now, let's see what we got to do. We have to find these things called x and y intercepts. And what an x and y intercept is it's just what it sounds like. It's an intercept. It's a point on the graph where it's crossing the origin at the x-axis and y-axis. So there could be multiple crossings. There could be only one crossing. There could be no crossing, technically, I guess, where it just never crosses. But you find it very straightforward process by setting your function equal to 0. So you notice f of x. This wasn't explained in my live streams, but if you've ever taken a math course about functions and it's explained in college algebra 2 that simply y equals f of x. And all of that's saying is it's distinguishing a relation from a function. I realize that you can't see it that far up because you just might not be able to. So look like I couldn't see it on my screen. Y equals f of x. Okay. And all that is that's distinguishing. So any relation can be called y equals. So it's how y relates to x. When you use function notation, what you're stating is it's actually a function. That means that there is a mapping where you're looking at values in your domain, and you're not going to have any repeating values in your domain. Okay. And you can see that by a table or visually looking at the graph. And it's an actual function is different from a relation. You can go back and look at definitions. But what this is stating, when you use f of x, all you're stating is this is a function. It passes that vertical line test. Okay, you take a vertical line, an imaginary vertical line, and you run it across your graph along the domain, and you don't see any duplicates, there's no double crossings, then that's the basic like way that you determine a function if you're looking at the graph. Anyway, that's a whole nother subject at it as its own, but basically, essentially, y equals f of x. So when you're looking at f of x, you're looking directly for the list of outputs. So you could, you would have x, and if you wanted to list it, you could say that this is f of x as well. And it's understood that it's y, it's the range. But what we're going to be doing is whenever you want to find where on the y-axis, and I'm going to change that back to y just because I like it better. The Cartesian coordinate system, x comma y. Okay, so I kind of lost my train of thought. If I want to know where on the x-axis y is 0, I'm looking at this line right here. It's the x-axis. Okay. So I can plug in if I want to know where this function is when x is 0, I'm looking at this line right here. Because every value on this line right here, x is 0. So what I'm doing is I'm setting the function equal to 0. So I'll replace f of x with 0 if I want to find out where it's crossing. Let's see, y equals 0 will tell me where it's crossing the x-axis. And then if I plug in 0 here for x, it's going to tell me the y-intercept. So that's what we'll start doing. We're just going to say f of 0. When is x 0? And we'll get, all we're doing is taking the function and plugging in, when you see an x, you're replacing it with 0. So you'll have 0 squared plus 5 times 0 plus 4 divided by 0 minus 3. And it looks like 0, 0. So this is going to be 4 in the numerator, and 0 minus 3 is negative 3. So this is giving me a value of 4, negative 3 when x is 0. So when x is 0, that's my y-intercept. So I'm going to say over here, y-intercept okay. Sorry, so that would be y equals 4. Was it negative? Yeah. So it's going to be negative 4 thirds. All right. So we've got that out of the way. We're now going to, instead, when we're wanting to know where it's crossing the x-axis now. So we're going to make the function, so we're replacing y with 0 now, because that's going to tell us this line right here is the y equals 0 line. So where is the function crossing that line? It's when the function is 0 now. So you have 0 equals x squared plus 5x plus 4 divided by, and if I write on the left side of the board, I realize, I'm learning the hard way. It's harder for me to show what I'm writing because I'm left-handed. All right, we're going to evaluate the function this way, and a little bit of algebra and rules for properties of real numbers allows you to establish this equality. So what I'm going to do is I'm going to multiply to remove x minus 3 from the denominator. I'm going to multiply both sides by x minus 3. And then 0 times x minus 3 is just 0. So I have 0 equals, and then these are going to cancel. So then I'm left with x squared plus 5x plus 4. And this is a quadratic. It's a second degree polynomial. And so there's 3 ways to solve this. Use that property of symmetry and state it this way. It looks a little bit better. X squared plus 5x plus 4 equals 0. 3 methods of solving quadratics, and maybe we'll get into those because I really, really like quadratics. So that might be good for us to get into next. But the 3 ways you solve quadratic, factoring is the easiest because if it factors, it's down the easiest. The second method is the quadratic formula, which most people will prefer that one because it's just plug in and you're literally just plugging in values and it's not a lot of thinking involved. So you don't really have to articulate a method. You just simplify that ugly equation and then you get an answer. So it's very straightforward. And then completing the square. You can complete the square. And so those, I really like the completing the square. So if we do get into quadratics, I'm probably going to go ahead and nerd out a little bit and do the completing the square method just because I enjoyed it. All right, so this one, I believe it does factor. So we'll just factor it real quick. And then the game is I'm finding 2 numbers. When I multiply, I get this number. And when I add those numbers, I get this number. And I can see that's 4 and 1. 4 times 1 is 4. 4 plus 1 is 5. So I've factored that one. And if it doesn't factor, you can still find those zeros. You would use the formula, which is good for every well, the quadratic formula and completing the square will work for any of them, but it's just you pick your poison, you decide which one you like best. Anyway, looks like we have 2 x-intercepts because when to find these actual zeros, we take each factor and set it equal to 0. So that's going to give us x plus 4 equals 0. And x plus 1 equals 0. And this is also the reason why those horizontal shifts are opposite. It's because the actual 0 is what you're finding from the factor. But anyway, we're going to subtract 4 from both sides to solve the one-step equation. And that's going to give us x equals -4. And doing that same thing here, subtracting 1 from both sides, and we're going to get x equals -1. And here are your actual intercepts. And then on this one too, I'll fix this one because I put y equals. It's not a line. It's an actual value. It's an ordered pair. It's when x is 0, y is -4/3. Okay. And similarly, adversely, the x-intercepts. Okay, there's 2 of them. This is when y is 0. Okay, so we'll have x comma y, y is 0 in both cases. Okay, and x is -4, and x is -1. All right. So these are the values whenever I go to graph any function in the world again. I want to find these values because these asymptotes, what they're doing is they're partitioning your graph. It's telling you where your graph is seeing all the action. And then the y-intercept and the x-intercept is the natural partition from the Cartesian coordinate system. So you want to know like where this graph is, doing its thing. Okay. And these critical values right here, I find first. All right. So, already 30 minutes in. I need to learn how to be more concise. It's just that I feel like the world is in such a big hurry, man. You gotta take your time with it. You really have to dedicate the time and not get in such a rush. And I don't have any questions anyway, so this is good for me. All right, so what I'm going to do is I am going to sketch the graph of this function, and I realized that I already have to increase my y, so I'm going to have to change the scale of my y, unfortunately. And hopefully after I get all this set up, it'll go pretty quickly. But I have what's happening when I sketch this graph. So I'm going to want, see how far I can skip this up. I'm going to change the scale on the y-axis. So we'll do we're going to change the scale. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just on the y-axis, not the x-axis, okay? So it'll just be kind of, it'll be all right. -1. And I'm going to have to do that as well. I'm going to have to do it as well here. So we're not going to increase it anymore. We're just going to change it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's really hard for me to plan because I just that should be good enough. All right. I'm having trouble lesson planning for this live stream because I don't really have any constraints. That's making it harder for me. It's like if you tell me what to teach and when to teach it, then I have a direct guidelines, parameters. I don't have any. It's just, oh, do whatever you want. All right. And the reason why I did that is because whenever I go to sketch my oblique asymptote, this line right here has a y-intercept of 8. So I have to be at least here. I recall sketching the graph of a linear function here. So you locate your y-intercept. It's y equals mx plus b. And let's see, should I do the caveat and do it? All right, I'll just do it. So you have I'll just do it here, and then I'm going to erase it because I don't want it to mess up my graph. You have y equals mx plus b for your form. So in math, we like our forms. It's just like, forms are just like anything, like you would go and apply for a job online, you'd have to put your information into a form. And this is very similar. So you have m is your slope, and it's always the coefficient of your variable x. And then b is your y-intercept. So to graph a linear function, you locate the y-intercept, and then you perform the slope rule. And slope is rise over run, essentially. So you're looking at the coefficient and making a fraction out of it. So in this case, my coefficient of x is 1. So my slope, my m, is 1 over 1. So I'm going to locate my y-intercept at 8, and I'm rising 1 and running 1 to find my next point. And then you could also do m of negative 1 over negative 1, which is also positive 1. And so you could go negative 1 and then fall 1 also to find values on the graph. So you're rising up 1, running 1, so it's a relationship that way. And notice it's starting to look a little curvy, so we're just going to get out our ruler and try to make this as straight as possible. And then what you could also do with this same function here is you can find your x-intercept, and you find it when y is 0 on your x-axis, and you would just make that function 0. So you'd say for this y equals x plus 8, if I want to find out where it's hitting the x-axis, I just replace y with 0 and figure out it's x plus 8. So you subtract 8 from both sides, and you get x equals negative 8. Down here. So then I just line up those 2 points. So to sketch an accurate graph of a linear function, you only need a minimum of 2 points. And I'm going to dot this one because this is actually my oblique asymptote. Dashing it. Dashing. All right. And just trying to do a good job here. Be thorough. That looks pretty good. Clean. All right. And I'm going to go ahead and sketch my vertical asymptote. There's one at x equals 3. And see how straight I can get it without. Go ahead and that's this little right now. Worse. So we've got a dash on 3. Of course, it's not going to be as pretty as the one that had the ruler, but just need to pick up the pace a little bit. I'm goofing around here. I need to get back to business. All right, so those are our 2 asymptotes, and then let's go ahead and plot these 2 intercepts. So we have a y-intercept at 4 divided by 3. So let's see. 3 divided by 4 goes in 1 time. 1 left over. It goes into 40 more than 3 times. It's almost, it goes into 10 3 times. Sorry. Yeah, 3. And then that would be 9. And then it would repeat. Okay, so negative 1.3 is going to put me about right here. Okay. So I've got my y-intercept graphed, and then my x-intercepts, there's one at -4. And there's one at -1. All right, so what I want to do is it looks like I did not leave enough room up here for any of these points to show up. So I'll have to, let's see, we're going to evaluate it at, I'm trying to figure out where I want to evaluate this function. So I definitely want to know what it's doing on both sides of this vertical asymptote here, and also right in here. Okay, so we'll go ahead and start there. I'm going to go ahead and say, figure out -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. And let me scoot those down just a little bit. 2, 3, 4. There. Man, I don't know why I have to get so crazy with all this circling. Okay. All right. And this is taking me a lot longer than I wanted it to, but with these values right here, we kind of already know the general behavior of this graph because it's approaching this asymptote and it's crossing here. It's also crossing here. And it's also approaching this asymptote. So I can already say I know where what this function is kind of doing. And then there's got to be something over here. But let's go ahead and plug these values into the function and see how to evaluate it. So if I want to know where f of -7, for example, then I'm just going to replace x squared with -7, use a parentheses, plus 5 times -7 plus 4 divided by -7 minus 3. And then I would repeat this process. So we'll do it once, and then I'm going to plug this in my calculator and find these other values. So that's 49. -7 times 5 is -35 plus 4. And then -7 minus 3 is -10. So you do the math, 49 plus 4 is 53 minus 35 divided by -10. And then 53 minus 35, see 35, 40, 45, 50. So what is that? 15, 16, 17, 18? Is that 18? Divided by -10. And then you would reduce that down. Half of 18 is 9, half of 10 is 5. So you would go in -9/5. And I realize how late it's getting. So I better, since I've got my batteries charged on my calculator, better just go ahead and if I can figure out how to get multiple cameras up during my live stream, I have no problem like putting calculator on here and maybe even giving some students some help on the calculator. But you can plug this whole thing in, store variables in, and just check it really quick. So these things are really handy for evaluating functions. So I'm just going to type it in, and I only have to type it once because it'll store it for me. Which I probably should have done this before my live stream, but this is how I learn. Okay, so I have it in there. And so now I'm just going to go through here and put these on. So I want to check -7. And it's saying -1.8 math. Do math fraction form. Yeah, -9 fifths is correct. So we'll do -6 store for x. And it's saying this is -10/9. So we've got 10/9 is math fraction form. So it's -1.1. And then so on and so forth. And we'll do a couple more. -5 store for x. And -1/2. So -5 is -1/2. -4 store for x. Now that put me at 0. We already knew that. There's also a 0 at -1. -3 store for x. And it's saying 1/3. Positive 1/3. So -3, as I suspected, jumped up. It didn't jump up as far. It's not like that. Because it doesn't make it to 1. It's just barely over the axis. Okay. And then -2. On math. That's 2/5. -1 was 0. 0 was -4/3. That was from my asymptote or my intercept here. And then 1 store for x. -5. So at 1, we're at -5 here. So I was really close, not quite on this one. And then C2. -18. So 2 we're already all the way down. So it went all the way there. Past the graph, because we're only going to 10, remember. And so let's check. This is -18. It's not going to be on the graph. 3 was our undefined value. So 3 will be undefined. There would also be, well, no, at -8, there's actually value on there. So, all right, so 4 store for x. I'm almost done. Is 40. So we're at 4. We're way up here off the grid. But by the time we get to 5, is at 27. Here, let's check 6, just for fun here. Script for x is at 23. 7 store for X. I'm just trying to see if there's a value I can fit. So it's still all the way up in the 20s at 7. See, how far would I have to go on this table, X comma Y? At 7, I'm still at 22. Let's do 8. And then taking it too far after this, we'll just stop. 8 store for X. It's 21.6. So I'm still not even showing up on 8, 9, 10. So there's something going on in the graph up here, but we can't see it yet. Because I feel like I might have picked a bad function, but I was trying to find one with no oblique asymptote because I don't know, I think they're different, they're cool. And I feel like the more that you see the math, the more comfortable that you'll get with it, hopefully. All right, so I better call it good because that was, it took a lot longer than I thought it would, to be honest. And that's part of the learning process, so I'll just go with it. And I'll just count that as another success because I feel like every day that I'm showing up for the camera is a win. So I'm trying to discipline myself to be here Monday through Friday from 6 p.m. to 7 p.m. Central Time. Just in case anyone wants to show up and ask a math question. And so I really appreciate you tuning in and watching my videos. And I look forward to seeing you next time. So I'll go ahead and end it there. Bye.